What up, it's your boy C Rizzy coming at you with Unit 2, Lesson 6, Proving Angles Are Congruent. Your joke for today. Did you hear about the mathematician that was afraid of negative numbers? Wonder what happened to that guy. Your essential question is, when am I ever going to use those postulates and properties we learned about in Chapter 1? And our objective is to prove and apply theorems about angles. Congratulations, today is that day. Because you can use given information, definitions, properties, postulates, and previously proven theorems as reasons in proofs. That's right, proofs. So let's talk about a couple of different theorems. One, the vertical angles are congruent. So we talked about vertical angles back in Chapter 1, Section 4 or 5, one of them. But what they didn't tell you in that is the theorem about vertical angles in which they are congruent. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Congruent supplements theorem. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So if angle 1 and 3 are supplements and 2 and 3 are supplements, well then 1 must be congruent to 3. So let's just think about this logically. If I told you angle 3 was 120 degrees and angle 1 then must be 60, that would make angle 1 and 3 supplements because they add to 180. Well, if 2 and 3 are supplements, I already know 3 is 120, which means that 2 would also have to be 60. Therefore, by the congruent supplements theorem, angle 1 and angle 2 would be congruent to one another. Obviously, if that holds true for supplements, it also holds true for complements. If 1 and 2 are complements and 3 and 2 are complements, then angle 1 is congruent to angle 3. So again, let's say angle 2 is 60 degrees and these angles are complements, then 1 would have to be 30. And then if 3 and 2 are complements, well, I already was told that angle 2 is 60, so 3 must also be 30. Therefore, angle 1 is congruent to angle 3. All right angles are congruent. Pretty self-explanatory. We defined right angles as being angles that measure 90 degrees. Therefore, they must be congruent. If two angles are congruent and supplementary, then each is a right angle. So if angle 1 is congruent to angle 2 and they're supplements, then they must be both right angles. That just makes sense. Because if they're congruent to each other and they have to add to 180, then they both have to be right angles. The same way, if two angles are congruent and they're complementary to one another, then they must both be 45. Alright, so what's the value of x? This is simply vertical angles theorem that says this side is congruent to that side, which means that if they're congruent, by definition of congruence, they're also equal to one another. So 2x plus 21 equals 4x. 21 equals 2x by subtraction property of equality, and then by division property of equal. If I divide by 2, x equals 21 halves, which is 10.5. Okay, given that angle 1 is congruent to angle 4, prove that angle 2 is congruent to angle 3. So what I'm going to do here is I'm going to write a two-column proof. And what does every two-column proof has? It has statements and it has reasons. The first statement to any proof is what I've been given. Angle 1 congruent to angle 4. Reason 1. Given. And what I need to get to, my last statement, has to be what I'm trying to prove. So if angle 1 is congruent to angle 4, well, let's see, what else do I know is true? Let's see, by vertical angle theorem, I know that angle 4 is congruent to angle 2. That's by vertical angles. Vertical angle theorem. What else do I know is true? Well, I know 1 is congruent to 3 by vertical angle. So what am I trying to get to? 2 and 3? So I already know, so another way I can do this is I know that 1 was congruent to 4. I know 4 is congruent to 2. So I could say that angle 1 is congruent to angle 2 by transitive property. And I already said 1 was equal to 3. Well, if 1's equal to 3 and 1's equal to 2, then lastly I can say that 2 is equal to 3. And there's two ways I can write this. I could write this as transitive, or technically I could write this as a substitution. Okay, angle 1 and 3 are supplementary, 2 and 3 are supplementary. Prove that 1 is congruent to 2. So again, statements, reasons. Okay, so what's the first thing I put are my given statements. So I'm just going to kind of bracket these and just put them there. Number 1, given. Okay, so 1 is supplementary to 3, 2 is supplementary to 3. Automatically off that supplementary statement, I want to say something about angle 1 is congruent to angle 2. What's my reason? Well, that's just the, what was that? The actual definition was, theorem, what was it, 2.2, congruent supplements theorem. So by congruent supplements theorem, then I know 1's congruent to 2. There's my proof statement. Therefore, that proof is done in 2 statements. All right, that's all from me. But to finish my joke, did you hear about the mathematician afraid of negative numbers? He will stop at nothing to avoid them. Stop at nothing like 0. That's a good one. See you guys tomorrow.